is going to be on systems of equations utilizing multiplication. And what that means is we're going to manipulate the equation and we're going to create equivalent equations. We know certain things about equivalencies. We've seen equivalencies before with fractions. So when you have a fraction and you create an equivalent fraction, you multiply the numerator and denominator by a common value, which is like multiplying by 1. So we don't change its value, we change its look, its facade, as I always explain. So we know that 1/2 and 3/6 are equivalent to each other. So that's a nice way of showing how we're going to create equivalencies. If we have an equation like x plus y equals 4, we can create an equivalent equation to this by multiplying everything by 2, much like we did in finding equivalent fractions. So an equivalent equation would be if we multiplied everything by a value of 2. So we know that this equation is equivalent to that equation. It's kind of neat. And how do we use that? Or how are we going to use that with systems? Well, we had this before in the systems. We would combine the two equations, and it was beneficial for us to combine them because it would cancel out one of the variables. So if we have, not equivalency, systems of equations elimination. So let's just throw one up there. Not that one. Not that one. Oh, it's not interesting. Why is that? Oh, there you go. Sorry. That makes it so much easier. Not that one. All right. Oh, not that one. What is going on? All right. That's a good one. So all those other ones were special cases. We haven't discussed special cases just yet. We will, though. All right. So in the homework last night, when we had addition, and we called it addition, which eliminated a variable, and that's what we needed. We can't solve for these a variable because we have two variables in each of the equations. But if we add them, if we combine their columns, if we add, and when we add, we're adding like terms. So 3x and x makes 4x. Positive 2y and negative 2y, they cancel. And then adding the constant, -1 and -3, gives you -4. So now we went from adding these two equations where they cancel out one of the variables, and now we can solve for the variable. We couldn't solve when we had either of these. So this gives us x equals -1, and then we can plug it back into one of those equations. We'll take this, x minus 2y equals -3, plug in the -1. We're going to add 1 to both sides. We get -2y equals -2, divide by -2, and we get y equals 1. So my solution is going to be -1, 1. So that is addition. And why were we able to use it? Because when we looked at it, we noticed that one of the variables were opposite of each other. And when they're opposite of each other, they're going to cancel out. So that was very conducive. If we look at this equation, our first example, we look at our x's, -9x, -7x. If we look at our y's, no, that's not the color I wanted. We look at our y values, or coefficients. You have positive 16y, -8y, and then we look at our constants, and they actually are opposites. But this is not a great equation because If we choose to do the addition method, we get negative 16x plus 8y equals 0. And what's wrong with this? What's wrong with this is we still have two variables. So what was nice about adding these two is one of the variables canceled out. The y's canceled. So that's why we use the addition method. If we use the addition method here, nothing cancels out. So we can't use the addition method. At least we can't use it at this point. But we see that we're kind of close with one of them. We see that, yeah, these are kind of close to each other. We're almost there. We see that they're not opposites, but they're kind of opposites. One's positive, one's negative. One is positive 16, one is negative 8. So we're not there just yet, but is there something we can do? Can we write an equivalent equation to this one, which would make the negative 8y a negative 16y? Because if this ended up being negative 16y, then it would cancel with this one. So can we multiply this equation by a value that would make it negative 16? Much like when we multiplied, we wrote an equivalent. We multiplied everything by 2. Can we multiply this? Well, yeah. In fact, we can multiply this one also by 2. If we multiply and write an equivalent fraction, so 2 times negative 7 is negative 14x, sorry, negative 7x. What is positive 2 times negative 8y is negative 16y. And positive 2 times negative 23 is negative 46. Now, if we bring our original top equation, negative 9x plus 16y equals 23. So I didn't manipulate, I just brought it over. And now we do the addition. We notice that this time our variables do cancel out. And it leaves us with just one variable. That's negative 23x, and that gives me negative 23. What's great? We only have one variable here. Now we can isolate. We get x equals 1. And then we can choose any of these equations. I'm going to just choose the bottom one. Someday this smartboard will work for me. I'm going to plug in 1 for x. And we like this because, again, our variable cancels out. We had 2. We substituted this value in for x. And what it did was it canceled out one of those values. And when we cancel out, that allows me to solve for the leftover variable. 23 is going to be negative 16 divided by negative 8 gives me y equals 2. And my solution is 1, 2. I'm going to go back and just make sure, check that top one. 1, 2, that's negative 9. 2 is positive 32. Negative 9 and 32 gives me 23. So that worked. That is the correct answer. Well, that was interesting. All right, let's delete that extra page. Delete page. All right, number 2. So our first thing is we want to see, do they cancel? Do my x's cancel out? Nope. They're not opposites of each other. Do my y's cancel out? Nope. They're not opposite each other. So I can't just use the addition. I'm going to have to manipulate. I'm going to have to write an equivalent fraction to, or equivalent equation to one of these. I'm going to have to manipulate it by multiplying it. So which one do I want to choose? Can I multiply 3 by a value to get my top one to get opposite of my top one? No, 3 times nothing gives me 5. So I'm probably not going to cancel out the x's. If I look at my y's, I have -10 and +5. Ah, yes, they're multiples of each other. So when we look, we're looking to see if they are multiples. That's going to lead me to believe that I can multiply one of the equations. So I may not have to do both. So I'm going to look to get rid of the y's. So what do I multiply the bottom equation by to get rid of the y's? We're going to multiply it by 2 again. So my top equation, I'm not changing or writing an equivalent. I'm just writing the original equation. The bottom one I'm going to multiply by 2. Everything by 2. Has to be everything. So 2 times 3x is 6x. 2 times 5y is -10y. And 2 times -13 is -26. I did 2 because I knew I was going to be canceling out my y's. And I made a mistake. You see that? And I know I made a mistake because -10y and -10y do not cancel. So I got to go back. 2 times 5y is +10y. So I did the right number, I just didn't multiply correctly. So these cancel. -5x and 6x gives me x. +30 and -26 gives me +4. And we love that one. That one's even nice. That gives me my variable isolated already. So I'm going to pick an equation. I'm going to pick the bottom one just because it's closest to me. And I'm going to plug in 4 for x. And I'm going to simplify. And then I'm going to isolate. I'm left with 5y equals -25. Divide by 5, divide by 5, y equals -5. So my x value was 4. My y value is -5. And I'm going to go back, make sure. I'm going to test in that top one. That gives me -20. That gives me +50. -20 and +50 gives me 30. So it equals the right side. Let's try number 3. So looking, what am I going to choose? I'm going to choose, because my y values are multiples of each other, my x's that would have been a little bit more challenging. We're going to do those problems on problem number 6. So those are coming, but we're just working on this. So what do I multiply? Again, I'm going to multiply by 2. Is it always going to be 2? No. Mr. Max should have probably done a better job of making sure that you're not multiplying the same bottom equation. But this is still good practice. We're getting the hang of all this. We multiply everything by 2. 8x times 2 is 16x. 2 times -7y is -14y. And 2 times -5 is -10. My y's cancel out. I'm left with, what's that, 7x equals +14, divide by 7, divide by 7, and we get x equals 2. Pick the bottom one. You have 8 times 2 minus 7y equals -5. 16 minus 7y equals -5. Minus 16 minus 16. -7y equals -21. Divide by -7, divide by -7, y equals 3. So my solution is going to be 2, 3. Go back. Does 2, that's -18. And 3 is +42. 18 from 42 gives me 24. So that worked. Yes, but it's still wise. So look at this. These are not multiples of each other. So I'm probably not going to look to cancel out the x's. I can't multiply this equation by a value to get 10. And I can't multiply this by a value to get 8. So that leads me to believe that I have to isolate the y's. Now, the y's are a little bit tricky. They're close to each other, but they're totally not close. So I need this y not to be a negative 11y, because negative 11 doesn't cancel with negative 11. I need this to be a positive 11. So I'm going to multiply the top equation by negative 11. Well, you'll see. Let's do it and see what that gets. So negative 11 times 10x is negative 110x. Negative 11 times negative y is positive 11y. See how it's opposite of that? So I had to multiply this value that gave me the opposite of this value, which is positive y. So I had to do a little tricky thinking there. And then I have to multiply the negative 11 times negative 17, which is going to give me positive 187. Didn't need a calculator, because multiplying by 11 is actually really easy. Ask Mr. Mac someday what the trick to multiplying 11 is. It's very, very simple. All right, now we have our y values are opposite of each other. That's nice. We have negative 110x plus 8x gives us negative 102x equals 14,204. Divide by negative 102, divide by negative 102, x equals negative 2. You thought those were big numbers? We're going to give a big answer? Not the case. It gave me a nice, convenient negative 2. So I'm going to pick the lower equation. I'm going to plug in the negative 2. I get negative 16 minus 11y equals 17. I'm going to add 16. Negative 11y equals 33. I'm going to divide by negative 11, and I get y equals negative 3. So my solution is negative 2, negative 3. Let's go back. That gives me negative 20. This gives me positive 3, which gives me negative 17. That's got to be a negative 11. And that's my answer. So that worked. Number 5. Okay. Ooh. All right. So the easiest one is going to be y. And I choose the y over the x's because I don't have to worry about the signs. The signs are opposite of each other. So all I have to do is multiply the bottom one by a positive 2. But let's do a little, no, I don't know what happened there. What? Oh, that's a full page, that's why. Let's duplicate, clone page. What if we wanted to do the x's? Let's just do for fun. What if we wanted to do the x's? Now we have to be aware that the signs are the same. And we know the signs have to be opposite of each other. But 2 and 8 are multiples, so that's why I thought it was okay. Or it is okay. So what if I multiplied, what would I multiply negative 2 to get the opposite of negative 8? What do I multiply negative 2 to get positive 4? Or positive 8, I'm going to multiply by a negative 4. If I multiply by a negative 4, that gives me positive 8x minus 64y equals negative 56. That's a horrible 5. Negative 56. The bottom equation I'm just keeping because I got rid of the x's. So you see that the x's cancel out because they're opposite. By combining the the y's gives me negative 72y equals negative 72. Divide both sides by negative 72, we get y equals 1. Let's choose the top equation this time, just for kicks and giggles. This pen is not working very well. Negative 2x plus 16 times 1 equals 14. Negative 2x plus 16 equals 14 minus 16. Negative 2x equals negative 2. Divide by negative 2, divide by negative 2, x equals 1. So my solution is going to be 1 comma 1. Let's check. Yep, that worked. Now let's go back to this. We can write or, because this is or. So we'll go back to this one, canceling the y's, because this should be a little bit easier. So we don't have to manipulate the top equation because we're going to cancel out the 16y. If we multiply it by a positive 2, we get negative 16x minus 16y equals negative 32. We get negative 18x. The y's cancel out. Right, we saw the x's canceled out in that one. This one we're canceling out the y's. Equals negative 18. Divide by negative 18. Divide by negative 18. We get x equals 1. Does that coincide with that answer? Yes. And then we can pick the top equation again. We get negative 2 times 1 plus 16y equals 14. Negative 2 plus 16y equals 14. Add 2, 16y equals 16. Divide both sides by 16, we get y equals 1. So it doesn't matter which one you cancel out, you're always going to get the same equation. So we canceled out the y's, which gave us the x first, and then plugged back in to find the y. In this instance, we canceled out the x's. We got the y, plugged it back in to get my x value. So still the same answer. It doesn't matter. All right. So here's where it gets interesting. Here's where we can't just multiply one equation, because no number, I can't multiply anything by negative 3. Well, I can, but no whole number by negative 3 to cancel out with the negative 4x. And on the like side, there's nothing that I can multiply this positive 3y to get the opposite of negative 10. And there's nothing I can multiply by negative 10 to get the positive 3. So, of the two, which one should I choose? I'm going to have to multiply both equations. I'm going to have to find a common multiple of these numbers. So what's going to be the easiest? Well, I'm going to choose the y's. And the reason why I choose to cancel out the y's are because the signs are opposite of each other. So that's one less thing that I have to worry about. If I was going to do the x's, notice the signs are both negative. I'm going to have to multiply one by a positive, one by a negative, and it just creates a little bit of issue. So if we look at 3 and 10, what's the lowest common multiple? That would be 30. So what am I going to multiply 3 to get 30? I'm going to multiply the top equation by 10. And what am I going to multiply the bottom equation to get 30? Negative 30. They have to be opposite of each other. So I'm going to have to multiply it by positive 3. So if I multiply everything in the top by 10, gives me negative 40x plus 30y equals 90. Don't forget to multiply all three. Students will make the mistake of not multiplying the constant. And now let's multiply the bottom. We get negative 9x. We get negative 30y equals negative 90. Ooh, that's an interesting one. So each one, and my objective was to cancel the y's. So make sure your y's are opposite of each other. Do they cancel each other out? Yes, they do. When we add the two equations together, we get negative 49x equals 0. Let's divide both sides by negative 49. We get x equals 0. Ooh, that's a fun one. We haven't had that before. And now let's pick an equation and solve to find the other variable. So we get negative 3 times 0 minus 10y equals negative 30. 0 minus 10y equals negative 30. Negative 10y equals negative 30. Divide by negative 10. We get y equals positive 3. So I'm saying my solution is going to be 0, 3. So let's take the other equation. 0, 3. Does 9 equal 9? We should be good. So I'm picking and choosing negative 5x, negative 2x, negative 8y, positive 10y. Ooh, I like this. We again will choose the y's because they have signs that are opposite, but this will be fun. So you actually have a couple choices here for your common multiple. 80 is definitely a common multiple, but it's not your least common multiple. So could you multiply by 10 and 8? Absolutely. Some of you did that, but that'll give you big numbers. You could have multiplied by 5 and 4. Ho ho. All right, I see what you did there, Mr. Mac. So if we multiply by 5, you get negative 25x. You get negative 40y. And we get negative 45. If you multiply the bottom equation by 4, you get negative 8x. You get positive 40y. And you get negative 120. So notice that 40 ended up being our LCM, least common multiple between 8 and 10. So 80 would have been a common multiple, but 40 is the least common multiple. So it'll save you some big numbers. This gives us negative 33x. This gives us negative 165. Ooh, that's an interesting, where did Mr. Mac do a mistake here? That looks good. Let's check. Negative, negative. That's negative. That's negative. That's negative. That's positive. That's negative 120, 165. Oh, 5. Yeah, so it does. Yeah, all right, here we go. Mr. Mac just didn't do the math. So we get x equals 5. I thought that it wasn't going to go in, but it did into a nice number. Let's use an equation. I'm going to choose the bottom one. Negative 2 times 5, because I'm substituting it in and isolating for my y. I have negative 10 plus 10y equals negative 30. Add 10, 10y equals negative 20. Divide by 10, y equals negative 2. So my solution is 5, negative 2. Let's go back. So that gives me negative 25. That gives me positive 16. And that gives me negative 9. See how quick a check takes? It's really not that long. All right, I like this one. This one's a good one. So here's an example where we could use either one. I like the x's because the signs are opposite of each other. Or I like the y's because the y's are opposite of each other. So we can do either one. I'm going to choose the x's because we have yet to do an x. And my numbers are 6 and 4. So we can do 4 and 6. We can multiply this by 4, this by 6, and cancel with the 24. But there's an LCM. 24 is not the LCM, 12. So they both have 12 as a common multiple also. So I would multiply this by 2 and this bottom equation by 3. And I'm going to do that because I'm always going to be the efficient. I'm going to use the most efficient method. Equals negative 48. This gives me negative 12x. This gives me positive 15y. And that gives me 42. 42. My x's are going to cancel this time, which leaves me with 3y equals negative, not 3, that would be 6. Divide by 3, we get y equals negative 2. Plug it back in. I'm going to choose the bottom equation. That was an ugly 14. All of a sudden my hand went dead. Negative 4x plus 5 times negative 2 equals 14. Where did I get the negative 2? From here. It says y equals negative 2. So I'm substituting it in for the y in that equation, which leaves me only with one variable. And we know that when we have one variable, we can isolate and solve for it. We get negative 4x equals 24. Divide both sides by negative 4. We get x equals negative 6. So my solution is negative 6, negative 2. Let's test it in the other equation. That's negative 36. Plug in, that's plus 12, and we get negative 24. That worked out. Again, we can use either one because I like this. My x's are opposite signs and my y's are opposite signs. So we can cancel either one. If we want to cancel out the x's, we can multiply by 3 and 2 would be one way. That would be getting rid of the x's. If we wanted to get rid of the y's, we can multiply this by 5 and this by 8, which is going to give me a much bigger number. So I'm going to move away from that number. I'm going to go back and I'm going to do the x's. I like 3 and 2 with a common multiple of 18. So we get 18x minus 24y equals, that's 84. That is negative 18x. That's going to be plus 10y, and that's going to be negative 14. My x's cancel. I'm left with negative 14y equals, I think that's 70. We're going to divide by negative 14, and we get y equals negative 5. I'm going to take one of the two equations. It doesn't matter. Mr. Mac always has chosen the bottom one just for efficiency purposes. How many times did Mr. Mac say efficiency today? At least 4 times. Minus 25 minus 25, negative 9x equals, what's that, negative 32? 32, that doesn't seem right. Let's check our math. Mr. Mac feels like he did make a mistake somewhere. I'm okay with that. That's definitely negative 5. That's negative, that's good. Let's go back to the beginning. If we're going to take the time to check all of it. Make sure. All right. So these two equivalency equations are correct. I checked that. I'm checking the sum of them. That's good. Divided makes negative 5. Oh, found it. 5 times negative 5 is negative 25. So we're going to add 25 to both sides. And that's going to give me minus 7 is 18. So it's really good if you have a good sense of your work. Are you paying attention? Are you noticing whether you're making a mistake? Or are you noticing when you do make a mistake? So don't be afraid to stop. Check your work. When it feels like you're not doing it right, go back, take your time, go through from the beginning to the end. and you most likely will find your mistake. So negative 2 is negative 12. Negative 8 is positive 40. And that gives you positive 28. So the check worked. And take the time to check. Last problem. I'm going to choose, ooh, so neither are conducive. Positive, positive, negative, negative. So I'm going to have to be careful. I'm going to get rid of the x's. I'm going to choose to get rid of the x's. The multiple of 4 and 9 is going to be 36. But I have to be careful because they're the same sign right at the moment. So one has to be negative. So I'm going to multiply the top by negative 9 and the bottom by positive 4. That gives me negative 36x. That's plus 54y equals 0. And the bottom gives me positive 36x minus 16y equals 0. My x's cancel out. That leaves me with positive 38y equals 0. And make sure that that's 38, 12, 14, yep. Divide by 38, divide by 38, y equals 0. That's nice, I like plugging that in. 9x minus 4y equals 0. Let's plug 0 in for y. 4 times 0. So 9x minus 0 equals 0. 9x equals 0. Divide by 9, divide by 9. X also equals 0. So my solution is going to be 0, 0. Looks like a robot head, doesn't it? My name is Chatbot GPT. I know, I'm just messing around. Let's have some fun. So my solution is 0, 0. Who's not going to see that as a robot forever? I see it as a robot. All right, so let's check. 0 minus 0 equals 0, yes. So we are good to go. Those are all the answers to them. Hopefully you learned something. Hopefully you locked in what we were learning a little bit better. Appreciate it.